Welcome to Chibuzor Mathphysics. In today's video, I want to show you how you can use your calculator to find the eigenvalues and even the corresponding eigenvectors. It is a bit difficult and confusing when we try to evaluate and find the values of 3 by 3 matrices using the long method, that is by expanding this and finding the determinant. So I am going to show you how you are going to use your calculator if you have Casio 991 ES Plus second edition. It will help you to evaluate the values for eigenvalues and its corresponding eigenvectors. Of course, if you have TI-84 Silver Edition graphical calculator, that will be another powerful calculator that you can easily use to find your eigenvalues and its corresponding eigenvectors. But you see what we are doing here, this is a polynomial of degree 3. So it means that we are going to have 3 lambdas and try to open up the bracket. If we expand the bracket, we are going to arrive at the formula that will help us to get those eigenvalues. In dealing with eigenvalues, we simply need the equation a minus lambda I, and this must be equal to 0. What we are trying to say here is that A must be a square matrix. This is A. So they equate this matrix is 3 by 3 matrix. Of course, this 3 by 3 matrix is a square matrix with the order n by n. It is n by n because the number of rows is equal to the number of columns. So the number of rows must be equal to the number of columns for us to be able to compute and find the eigenvalues and the corresponding eigenvectors. I remain your friend Augustine Galagash, and stay tuned and enjoy the video. So the first thing you need to do is to multiply this. A is this matrix. So if we multiply this by that, we simply have, let's say that our new matrix is equal to 3 minus lambda. Then we have negative 1, 1. Negative 1, 1, we have negative 1, we have 5 minus lambda, we have negative 1, we have 1, negative 1, then we have 3 minus lambda. So this is what we have, and this must be equal to 0. Why? Because we are looking for the determinant of this matrix. So to do that, let us try to expand this bracket. Since we are dealing with 3 polynomial, I'm going to show you how to use your calculator. So let's say that we are having a lambda minus a multiplied by lambda minus b, multiply this by lambda minus c. So try to open up this bracket. You will get lambda cubed minus a plus b plus c lambda squared plus ab plus this is b plus bc plus ca, and this is lambda then minus abc, and this must be equal to 0. So this is the formula that you will try to expand this in order to help us generate the equation that we are going to use to evaluate the values for this eigenvalue and its corresponding eigenvectors. We used to say that this simply means that trace A is equal to A plus B plus C. And what is that? It means the diagonal of that matrix. So it is the diagonal. The diagonal here we are referring to the diagonal of this matrix is 3 plus 5 plus 3. What is that? This is 3 plus 5 is 8. 8 plus 3 is 11. So it will be 11. Now, what is AB plus BC plus CA? AB plus BC plus CA is simply trace of adjoint A. It is trace of adjoint A. And to find trace of adjoint A, this is AB plus BC plus CA, which is equals to the adjoint. To find that, we need ABC. ABC is simply the determinant. So let us pick our calculator and see how to find the determinant and use the determinant to find the adjoint. Stay tuned. So now what we need to do is to pick our calculator. This is my calculator. This is Casio FX991 ES Plus. So pick your calculator. If you have a calculator that is TI, I have that calculator but it's not here right now. TI 84 Silver Edition. You can as well use it to evaluate this. So let us put this on in this calculator. This is 3 by 3 matrix. So let's try to find the determinant. Go to matrix in your calculator. If you don't know how to use the calculator, you can watch my previous video. So let's take matrix number 1, 3 by 3, and put these values. We have 3 is equal to negative 1, is equal to 1, is equal to negative 1, is equal to 5, is equal to negative 1, is equal to 1, is equal to negative 1, it is equal to 3. So confirm the values: 3, negative 1, 1, negative 1, 5, negative 1, 1, negative 1, 3. Good. So let's find the determinant. The determinant is 7, determinant of matrix A, and that gives us 36. So the determinant for this matrix is 36. So now we can find the adjoint. The adjoint is simply go back to matrix. We are using matrix A. Take the inverse of this matrix, multiply by the determinant, which is 36, and you get the adjoint. So the adjoint we have 14 is 14 plus 8 plus 14, which will give us 14 plus 8 plus 14 is what? 14 plus 8 plus 14, that will give us 36. So now we are good to go. With these values, we are able to find the equation that we need. Here we have lambda cubed, so this becomes lambda cubed minus a plus b plus c. Our a plus b plus c is simply what? Diagonal, which is 11. So it is minus, because we have negative here, so it is minus. We have 11 lambda squared, because we have lambda squared here. And we have plus ab plus bc plus ca, which is the adjoint we also call 36. Look at 36. This is 36, so it is plus 36 lambda. Then the determinant is also 36, but we have negative here, so it is minus 36. And this is equal to 0. Plug this into your calculator and you will find the 3 values which are the eigenvalues. So let's do that. Take equation 5, option number 4. Let's take them. 1 is equals to negative 11 equals to 36 equal to negative 36. So now we find our eigenvalue. That's lambda 1 is equal to 6, lambda 2 is equal to 3, lambda 2 is equal to 3, and then lambda 3 is equal to 2, and then you are good to go. So this is how you can find the eigenvalues using your calculator. You must pay attention. First of all, work with this formula. Trace A lambda squared. We have lambda cube minus trace A lambda squared plus trace adjoint lambda minus ABC is equals to 0, so that you are able to find the eigenvalues. But if you don't know how to use this formula, then you have no other choice than to go the long way by finding the determinant of this 3 by 3 matrix. And you know, to find the determinant of this 3 by 3 matrix, you know you have to block the first row and each first column and take the corresponding rows and columns. You do the same thing in the second row, you do the same thing in the third row. So it will be a very long expansion, but that is the only way then you arrive at the end of it all. You must arrive at this equation, which is lambda cubed minus 11 lambda squared plus 36 lambda minus 36 is equal to 0. And this equation will give you these 3 values for lambda 1, lambda 2, lambda 3. So these 3 values of lambda 1, 2, 2 and 3 are the eigenvalues. So in the next video, we are going to use these values to find our corresponding eigenvectors. I remain your friend, Galagas.